We then just calculate the sample standard deviation, the sample variance. And you'll recognize this formula has two components. If you look inside the brackets, this is the standard formula for sample variance. We use an n-1 term to make it an unbiased estimator rather than n. And what's in brackets is an unbiased estimator of the variance of this random variable E, this E series. Now notice what's then done is it's annualized by dividing by h, the time period. This is consistent with our thinking of standard deviation as going with square root time. I'll just call this variance with a hat. That the standard deviation, if this is the estimator of the historical, then in order to create an annualized version, we would divide it by square root of h. To go from a period of h to a period of a year, we divide by square root of h. And this is just exactly the opposite of our typical application in a binomial tree or in Black-Scholes, where we say that the standard deviation for a period of length h is square root of h times the annual. So here we're calculating the annual from the period variance, so we're dividing by the square root of h, versus in our modeling, we're usually starting with the annual volatility and trying to create a subperiod volatility. So notice very carefully how this is done, that the period returns, we calculate the variance of them, and then we annualize that the variance by dividing by h. And it's important to recognize that if you annualize the returns, the e's first, and then calculate a variance, you get a variance factor that's way too big. And that's what this slide will conclude. But before I get to that point, let's remind ourselves that when one looks at the year, there are two measurements of the year. For all of us, the year has 365 calendar days. But of course, the market doesn't trade 365 calendar days. Estimated it trades about 252 trading days, which is roughly 21 days per month. So for the purposes of our scaling time factor, if we want to go from an annual measure to a daily measure, we should scale by 1 over square root of 252, not 1 over square root of 365. Research has been done on this question, and basically what it's consistent with is the notion that the the price change of securities from a Friday close to a Monday open tends to be quite small relative to what one would expect, which was observing that there are in fact 2 calendar days in between. So if you looked at Friday to Monday price changes, you might expect on average that would be significantly more than a close to from an open to an open, say a Monday open price to a Tuesday open price, or Monday close to a Tuesday close, because here we're now going a few days. And if you look at Friday close to, say, Monday close, you will find that those changes in prices are not nearly what one would expect if you thought that weekend days provided all the same information and all the same price volatility that trading days do. So this is a bit of a compromise, but one that's fairly well accepted and used. So if we're going from a year to a month, we use square root of 12. If we're going from a year to a day, we use square root of 252. If we're going from a month to a day, we use square root of 21, and so forth. Okay, so that's just going to be our timing assumption for the purposes of using historical data. But the point I made earlier is, in order to get an annualized volatility, it's very important that we do not annualize these period returns. And if we do the math, we'll see that by first annualizing these period returns and then calculating a sample variance, that we end up getting an answer that is too big by a factor of 1 over h. And intuitively, it's logical that this should happen, because imagine if we were making our estimates for daily volatility. If you looked at 5 successive days of price volatility, you would expect a certain amount of cancellation and offsetting from one day to the next. Namely, that the amount of volatility we get over 5 days would certainly not be square root of 5 often times the one-day volatility. On the other hand, that's a mistake, Dave. I'm going to go back and repeat that sentence. Okay, so I'm on slide 2316. So if we're looking at annualizing short period volatility, what we're doing is saying the volatility from Monday to Tuesday, which could be quite extreme because it's over a short period of time, if we annualize it and assume that that volatility happened over an entire year, it's intuitively logical that when we calculate the sample variance of those annualized returns, we're going to get a measure that's just too big. Because, in fact, the extreme volatilities we observe day to day do not usually manifest themselves into a comparable amount of volatility over the successive year. So it's intuitively logical that by annualizing the extreme volatility of, say, daily measures, we're going to end up with an annual volatility that's just too big. And so the approach that we saw in the prior slide is the one to take, and that is that we actually calculate the volatility measure based on the period returns and then annualize that. The calculation is quite simple, and that is if I go and I annualize this measure, and then I calculate the variance of these, the sample variance, using the typical formula. Since I'm annualizing the period returns, it would be logical to think that this variance estimate would give us an annual variance. But let's see what happens. We have a summation of epsilon I squared over h squared. And that's equal to 1 over h squared times the estimator we looked at a moment ago. In other words, this is 1 over h times the variance estimator we had a moment ago. Namely, by annualizing our period returns and calculating that variance, that does not provide an appropriate measure of an annual vol. And the intuitive reason is because short period volatility is not sustained over long periods. And when you annualize those short period returns, you're in a sense assuming that the annual volatility will follow the same pattern as the daily, but annualized. And that's just not the case. And you can see this error can be quite big, that if you were looking at daily data, it's saying if you annualize daily data, your variance measure is going to be off by a factor of 252, right? It's going to be quite 1 over h. H would be 1 over 252, and 1 over that is 250. You're going to be off by a factor of 250. That's a huge error. And you would know this immediately if you did an estimate. You would know that the answer you got was ridiculous because it was so big. On the other hand, if you did a monthly data, you would only be off in your variance estimate by 12, or quarterly data, you'd be off by 4, and you might not notice that as readily.